I will try to discuss with you and to review in the next 15 to 20 minutes the topic of high volume infiltration, and it's been said here in a very provocative way. Is it still indicated in clinical setting? So we have to discuss first the rationale, because there is still a lot of work to be done on this issue. Definition, that's more simple. There is a comparability between the efficacy to remove cytokine with high volume when you compare to other techniques. I will just touch upon this. There are another speaker that's going to address this. Is the technique really able to reduce vasopressors, has been said so many times in so many studies, even randomized? What about the removal performance of this relatively old technique, already in the year 90s, and the scope of the size of the molecule removed when we compare to modern technology like sorbent, discovered in the beginning of the year 2000. Technology is evolving, so then maybe mediator may not be always removable by convection ultrafiltration. Sometimes we need some adsorption. I will try to show you. We are also removing a lot of good things. That's a big issue. Do we have some new trials regarding this? There is some research agenda, and then I will give you the conclusion. Okay. So rationale. You all know this very well, this slide from Professor Ronco, so the so-called peak concentration hypothesis, saying that you have some storm of pro and anti-inflammatory mediators, and that you should cut the peak on both. Obviously, it's a relatively simplistic approach. The thing is to say and to look if it really works in terms of clinical grounds. And most of these studies, most of these theories were based on this very good paper from John Kellam already some 10 years ago, when he was looking at community-acquired pneumonia coming to the emergency department in the US hospital, almost 2,000 patients, and following those patients where they reached a step at the time of severe sepsis at the time. It was almost 1/3 of the patient. And then they decide to measure the level of a pro-inflammatory cytokine, IL-6, still debatable, and an anti-inflammatory mediator, IL-10. And then they plot the mortality at 90 days versus the level of the pro and anti-inflammatory cytokine. As you can see, when you have a high level of IL-6 pro, high level of IL-10 pro, your chance to die at 90 days about 50% almost. Whereas if you compare with a low IL-6, low pro, and low IL-10, low anti, your chance to die at 90 days only about 5%. So a huge difference. So making some sense perhaps in this so-called storm approach to sepsis dysregulation. Now, this paper is really very interesting because it's trying to go more in deep in trying to understand better when we have the window of opportunity perhaps to treat the patient with a blood purification therapy. And we have the infective insult. Obviously, most of the time we never know because patients are coming from outside the hospital most of the time. But nevertheless, we see first a rising in pro-inflammatory mediator and then after a rising in blue of anti-inflammatory mediator. And then you have three phases, very important. The first phase is called the A phase, and you see in blue here, you have very limited amount of pro in red and anti-inflammatory mediator in blue, and you have there a cutting point. And this cutting point is very important because it's a point where you can speak about a storm just in this region here, which is the B phase. So phase E, if you try to remove those low level of pro and anti-inflammatory mediator, you will harm the patient. It's too early. When you are in the B phase, and the B phase is stopping when the pro-inflammatory mediator are just below the anti in blue. It's a very small opportunity of treating. You have a storm of not only pro, but also anti-inflammatory above this level, which I will come back to. And then this is the window of opportunity. And then you have the third phase, the C phase, when you have indeed more anti-inflammatory mediator on board. And again, there is a counteractive anti-inflammatory phase restoring immune homeostasis. And this is very dangerous to touch on this because then you may again harm the patient. So you have only this very small window of opportunity to try to treat the patient. On this other side here, how can we define this level to say this is a storm and this is below the storm, so to say? Well, people are still thinking about what we should use. When you see the result of the ACCESS study presented in Brussels in March from the group from Budapest, they said this might be a PCT level above 3 nanograms. But other investigators said, well, we should perhaps use on the best side IL-6. When it's above 1,000 picogram per ml, we are perhaps in this storm zone. So far, nobody knows. And we are still stuck to know exactly when we are in the storm phase, in the B phase, when we could perhaps give some benefit to a patient when we are subjecting him to any type of blood purification technique. So rationale remains a key point. And ultimately, whenever we don't master the rationale of blood purification in sepsis, we may have the best possible study, the best possible statistic, everything on top, but we will miss the point. So we need to understand better, and it is far from being finished. Now the definition, more easy. It was a consensus conference held here in Vicenza, and then the paper was published in Critical Care in 2016, and defined as an ultrafiltration rate above 35 ml per kg per hour, or pulse high volume defined as ultrafiltration rate above 120 mL per kg per hour for a short period of time, at least 4 to 8 hours, followed by conventional CVVH. That's for the definition. Okay. We move on. So what about the efficacy? When we compare to, let's say, a high permeability, high hemofiltration. And in fact, I will just show this slide because another speaker will address this. But this study was done by the group of Bellomo already in 2006. And they were comparing standard iflux, but with an UF rate of 2.5 liters per hour. For a human body of 70 kilo, that's above 35 ml per kg per hour. That's high volume. And they were looking at the sieving coefficient of IL-6 clearance. Look at 30 minutes, 4 hours, 24 hours. Almost nothing removed by high volume. Almost nothing. And they said, well, look at the high permeability. up to 60 kilodalton instead of 35. We are removing 40-fold more, not only at 30 minutes, but at 4 hours, even at 24 hours. At the time in 2006, they said, well, probably we find the best technique to fix the problem. Later on, the story was changing, but this for the next speaker. So, not so fantastic to see what is the removal in convection. Okay. What's the effect upon the vasopressor therapy? So we did several studies, but also a randomized controlled study in 3 countries with Olivier Journes-Boyot from the University of Bordeaux and myself as PI, and Netherlands, Belgium, and France, and 18 recruiting center. And the paper was published in intensive care in 2013. And basically, we call this Ivory for high volume intensive care. And we evaluate 200 patients with septic shock and acute kidney injury. Well, still, at the time in 2005, we used the rifle criteria. And we were somewhat early on at the phase of injury, which was very early at the time. And we randomized 140 patients with a block randomization and a computer randomization in 2 groups, either 35 ml per kg per hour nor 70 ml per kg per hour. And we ran this for 4 consecutive days, changing the polyethyl sulfone membrane, not adsorptive membrane, after 48 hours in every patient. And then primary endpoint was mortality at 28 days. Secondary endpoint was mortality at 90 days and vasopressor requirement. And this is the result in terms of the primary endpoint. As you can see in red, the standard volume, 35 ml per kg, versus the high volume, 70. And you see at 28 days, no difference. Mortality was 39% in the 2 groups, nothing to say. And at 90 days, 51, 52, almost the same at 90 days. And you see the 2 curves are crossing many times because we were with an underpowered study, so we were asking if we could include more patients to see a difference. And the statistician said, well, whenever you have so many crossing of the curve, you may go up to 1,000, 2,000 patients, you will show nothing. Forget about this. But then we went to look in more deep the database as well, and we looked at the vasopressive free days, inotropic index, and so forth. And between the 2 groups, we find no single difference. We were very astonished because we say one of the main things said about high volume is the reduction of the catecholamine requirement. We could not show this at all when comparing the 2 groups. So this was already something that we were thinking more in deep. And almost at the same time, there was a nice pilot randomized controlled trial randomized for 20 patients with high volume and having a primary endpoint somewhat different, which is a 70% decrease in vasopressor dose after 24 hours. And the study was positive, published in Intensive Care Medicine. We decided with Sean Backshaw to do a meta-analysis, and we had at the time 4 eligible study with our Ivory study here. And we look at several issues, and we look at mortality at 28 days, and you see no difference favoring high volume. There was also no reduction in vasopressor requirement despite this positive study from the group from northern France, and also no difference in renal recovery between the 2 groups. So really fully negative, if you wish. Now, when we compare this old technique from the year 90s to sorbent, as I said, technology has evolved a lot, like any time. We have to make some difference, I think. In terms of size, there is something. We have an hemofilter that we use since the year 80. We have done a lot of amelioration in terms of adsorptive membrane, in terms of high flux, whatever. But still, the surface is 2 square meters, so about a ping pong table, not big. Whereas the cytosorb, the new sorbent, which is not too big when you compare to this hemofilter, somewhat thicker, I agree, but with a totally different technology, no capillary, but beads, they can achieve such a huge surface, 45,000 square meters in this sorbent that you can hold on your hands. Gosh. And you see that's about 4 football pitch. And if I just bleed now in front of you, but I'm in good hands, I'm only feeling perhaps the corner here of one of these football pitch. So how can we saturate this? Still a huge question, because, gosh. Anyway, that's a big difference. Another difference is that high volume has a cutoff of 35,000 Dalton. And we know the inflammatory mediator for the sepsis cascade do not make the difference about 35,000 Dalton. Don't know anything about this. They are far above. So we are missing all this mediator, especially with non-adsorptive membrane like we were using polyether sulfone. Whereas again, if you compare to a modern technology like cytosorb, look at this huge spectrum. From 0 to 65 kilodalton, they are taking out everything. So TNF alpha, interferon gamma, whatever you think, is out, except albumin, obviously, except endotoxin, which is about 100,000 Dalton, obviously. But anyway, you see that the capacity are really very different. We are not playing in the same division when we are using high volume versus this type of therapy, not anymore. So, we know also there are key mediators in the sepsis cascade that we missed when we use only convection. And this is a good example. It's a HMGB1, so high mobility group box 1 protein. It's a very important DAMS that is appearing almost 24 hours later than endotoxin. Somewhat late, but staying for a longer period of time. And the molecular weight of this is about 26,000 Dalton. So it's below the cutoff of 35,000 Dalton. So one would expect that whenever you apply convection, you get rid of this easily. Okay, let's see. This is a nice study done by a Japanese group when they compare this removal of HMGB1 in plain line in the treated patient and then the control. And they use to start a non-adsorptive membrane polysulfone, no difference. And they use a high cutoff, 60,000 Dalton, still almost no difference. And you need to really have very adsorptive membrane to have a sharp decline in HMGB1, and even better with AN69ST. So you have the best removal by this AN69ST adsorptive membrane. Why is this? Because you may have the same molecular weight, but a very flat molecule which is not going through the filter, and a globular one that can go easily through the filter. That's the reason. So removal of good things. To finish off, we know that we are removing a lot of trace element, nutrients, but also antibiotics. In 2003, we decided to do the ivory study. We asked a lot of experts to say, well, what to do with the antibiotics? should we adapt for the high volume dose antibiotics? And they respond to us, PK, PD in CRT, bullshit. So we give the same dose in the two groups. Then we find out in the sub-study we had a reduction of 50% in most of the antibiotics. So we underdose the high volume group. But if we had given the adapted dose, then people would say, well, because you give more antibiotics, therefore that was the reason. I'm just finished off. And then you say, well, good things, but now we know we have the cascade hemofiltration that was published recently in intensive care medicine, when the good things are retained by the low flux filter and going back to the plasma of the patient. And nevertheless, the primary endpoint was catecholamine 3 days, no difference, and mortality, no difference. So even though you are applying this, it's not making any difference. Last slide. Maybe on the research agenda only looking at this high volume with high filtration ratio means a lot of post-dilution. Maybe you can then also retrieve not only free cytokine, but also bound cytokine, like in this study where they show bilirubin inside the ultrafiltrate when the filtration fraction, filtration ratio was about 30%. My conclusion, if I may, so we are still looking out for a good rationale in blood purification. The way is still very long. Is removal that good when compared to high permeability? No. Is there an effect upon reduction of vasopressor? No. Are we playing in the same division when compared to sorbent? Surely not. Convection alone is not a good option. We need adsorption on top. What about removal of good guys? I show you cascade filtration is not fixing. With 10 negative RCT, there is not anymore any room for indication of high volume infiltration as an adjunctive therapy in sepsis. Full stop. And lastly, there is some research agenda, but that's all. Thank you for your kind attention.
Great.